Welcome back. In this video, let us understand what is Azure Queue Storage. Whenever we create Azure Storage account, so we get an option to create Azure Queue Storage very similar to the Azure Table Storage and Blob Storage. Let us understand when to use Azure Queue Storage, what is the scenario and what is the advantage of using Azure Queue Storage. And also let us understand the real-time use case when actually we can make use of Azure Queue Storage. So before that, please, if you haven't subscribed for this channel, please do subscribe and like this channel, and also don't forget to press bell button for instant notifications. So let's get started. Before actually jumping into the actual Azure Storage account, Azure Queue Storage topic, so let's understand why we need Azure Queue Storage, so that we can actually understand the problem better, and then so that by understanding the problem, you actually get to know the necessity of using Azure Queue Storage, right? So this is a problem, like whenever there is a application which is actually producing or emitting the data continuously to the another API or another application which is actually catching the message. So this might be a throwing the message to the other application. In this case, like if the application API, which is a producer, if it is transmitting the messages or transaction continuously to another application, so the problem here is, so if the consumer side application, right, which is actually consuming the messages, it might not be ready to take these number of messages, and the latency at which it is sending, right, the rate at which it is sending, the producer is sending, the consumer might not have capability to receive those number of messages. In that case, there might be a problem of data loss, or the consumer application may go down because of the if it is getting a lot of messages. So this is a problem, right? So in this case, I hope that you understood the problem. So let us see what is the solution that we can propose here. So this is actually, if you see, this is an event-based architecture. Like whenever there is a event, so event generated at a producer side, right? Immediately it is sent to the next consumer side. So this is an event-driven architecture where, so it, I mean, here it is like the pushing of messages is completely dependent on the event generation. It is not like so any batch messages, like we are not just dumping the data in a batch wise on a daily basis or hourly basis, right? As and when the messages is generated here in the producer, immediately it will be sent to the consumer. So this is an event based architecture. And in the real time, so since there is a lot of IoT machines and sensor machines, and there is a real time event that applications that are using, right? So this kind of scenarios are common in nowadays. So it makes sense to understand this problem. So if you understood this problem, so let's come to the solution. So in the solution, if you see, we have introduced an intermediate layer, which is more of a queue storage. What is queue storage? So queue storage will take the messages. If the producer is able to produce a messages like M1 to M6, right? So it will be, if you see, the order is different here. The first message M1 will be sent to the queue, and next M2 will be sent to the queue. So it is a queue, right? So if you understand the word by the word queue, so it will be like first in first out. So the first message will come first here, right? And next the message 2, it will be queued up basically. And whenever the consumer application is ready to take the message, it will first pick the M1 and next M2, followed by M3, M4, like that, right? So if you see, once the consumer application consumes the message, right, all these messages, it will be immediately deleted from the queue. So queue actually will not store any message. It acts just like a buffer. So it is a buffer area where temporarily we store the messages before actually being consumed by the consumer group or consumer API. So it is just like a buffer, temporary buffer, and it can have any number of message here. Like it can hold millions of messages, which is like more we can talk about the storage account capacity. And let us go to the next slide. So we'll actually see what actually Azure Queue Storage is, right? So Azure Queue Storage is, it will actually store the messages in first out basis, and it established the asynchronous behavior. So what is asynchronous behavior? I'll come back to the previous slide. So asynchronous behavior is nothing but whenever, so if you're directly connecting to in the previous architecture, if you see, right, so here we are directly, this is synchronous. Whenever the message is coming directly, it is being pushed to the consumer group. There is no time delay here. But when you talk about asynchronous, so there is a time delay here. We are keeping it in a buffer area and then pushing it to the consumer group, consumer API when it is ready. So this is called asynchronous. So there is a time delay in between, so which buffer is creating. So that is the asynchronous behavior we are talking about here. So it established the asynchronous behavior, and so these can be, I mean, the producer and consumer, what we are talking, right? The APIs are two systems can authenticate themselves using HTTP or HTTPS authentication. and it is straight hold, deliver, and delete. As I was mentioning here in the previous slide, if you see, it will just hold it and then deliver it once it is delivered to consumer, and it is just deleting it from the queue. So that's about it. And if you see here, the storage account, right? So when we create a storage account, inside storage account, we can create a number of queues. So basically, each queue is a logical representation of ordering. So whenever we want to have ordering thing, right? So this is basically how many orders you want, that many queues you can create. So if you see, it will be delivered in a order. So how we received, that kind of same order will be maintained. So that is the main importance of using queue storage. Now quickly let's see a quick demo of Azure Queue Storage. So I'm in the Azure Storage account, which we have created in the previous videos. And if I see the data storage, we have different options. So this is for blob and data lake, and this is for file and queue storage and table storage. So now I'm inside queue storage, and I'll create a queue here. I'm just giving some name to this, right? And so it will create a queue storage here. So once it creates a queue storage, we were discussing, right? It is basically a HTTP or HTTPS authentication. So that can be established using this URL. And I'll come inside this, and I can add a message here. So I can say message 1, and you can also set the expiry. So if the consumer is not consuming this message within this many days, it will expire, or you can also set the never expiry. So it depends on the requirement. And we are also having the encoding option if you want to choose that. But I'll just keep default, and I have sent one message to this queue storage, and so it is been created. Now I'll add one more message, which is Q2. Similarly, you can add a number of messages here. Basically, what I'm doing, I'm pushing the messages to the queue. But actually, in real time, what happens is, as you have seen in the architecture, right? So in real time, so this is what happens. The application will be throwing the messages to this queue storage using the HTTP authentication mechanism. In real time, this happens. But as of now, for the demo purpose, I'm manually adding the messages to the queue. So once I add this message, right, so the consumer application will immediately consume that once it is been received, and once it is consumed, so it will be dequeued. Dequeued means it will be deleted. So first message will be delivered, and next second message will be delivered, because that should be delivered in an order. So that's about it. Hope this was useful. Thanks for watching.